Hello students, in this video we will see how to solve the expression by considering the precedence and associativity. So suppose I have taken one example like x is equal to suppose is there like some values are there like 6 is greater than 7 is greater than suppose 2. This is what one expression. After that again another expression is like okay, y is equal to y is equal to suppose let's consider the 9 is less than 4 is greater than we can say 3, and suppose z is equal to 12 is greater than 15 is less than 3. So let's consider suppose these three are the expression and we want to print the values of x, y and z. So suppose percentage d, percentage d, and we want to print the values of x, y and z. So here what is the value of like x, y, z? So you can see here, here the relational operator is used like greater than or less than. So these two are the relational operator. Relational operator. So we know that the relational operator and equal to operator. So these two operators are there in my first expression. So here for relational operator having the higher precedence than the equal to operator. That means we are solving the right hand side first and then whatever value is there right hand side, then we are assigning that to the x variable. That means after that we are solving that equal to operator. Okay, so likewise that means first the precedence of greater than or less than is evolved or the calculated, and after that we are executing this equal to operator. So it is having the higher precedence and equal to having the lower precedence. So here now you can see that in my first expression, so let's consider this is my first expression. So in my first expression greater than and greater than, both two greater than operator are there. In my second expression, less than and greater than, these two are there. So these two operator like less than and greater than having the same precedence. Okay, that means if more than one operator is there in your expression having the same precedence, so that time what we are considering, we are considering the associativity of that operator. Okay, so here we are considering the associativity of this operator like greater than and less than. So for this less than and greater than having associativity is like from the left to right. Okay, that means you can see here, suppose my expression is like this. So this expression is solved from the left to right direction. Okay, so this is what associativity is telling. You can solve this expression from left to right. That means we are solving first this 6 is greater than 7. We are solving first this 6 is greater than 7. So if it is greater, it will return the true value, and if not, it will return the zero value or the false value. So here 6 is greater than 7. That means the condition is what? False. So it will return the zero value. Okay, now 0 is greater than 2. The remaining expression I have noted here, and this 6 is greater than 7, it returned the false value. So that's why it returning the 0. Now here we are checking that ki x is equal to 0 is greater than 2, condition is true. That means it returning the 1 value. So for x we are getting the 1 value. So same we are solving the second expression like y is equal to 9 is less than 4 greater than 3. So same again we are solving this expression from left to right. So we are checking first this 9 is less than 4, condition is what? False. So that is return 0. 0 is greater than 3, again the condition is false. That means it returned the 0. So here we will get the y is equal to 0 value for our second expression. Now we are solving the third expression like z is equal to 12 greater than 15 less than 3. So here we are solving first this 12 is greater than 15. So condition is what? False. So it will return the 0. 0 is greater than 3. So here condition is true. That means it returned the 1. So z is equal to what? We will get the 1 as the. Now you can see our next statement is printf percentage d percentage d percentage d x y z. So you can see x value is what? 1. So we will get the output as x is equal to 1, y is equal to 0, and z is equal to 1. That means 101. So this is our final output, like 101. Okay, after that, let's consider the another example. Suppose, so the another example is, suppose x is equal to, here suppose declaration is there, int x is equal to 8, y is equal to 2, and suppose only z is there. Okay, so z has not assigned any value. So if you see this, and suppose the expression is there like z is equal to y is equal to x, and x is equal to z. So you can see here comma operator is there. Okay, comma operator. So multiple or this comma operator is used for separator, or it is called as a separator of expression. That means for solving the expression, we are using this comma operator for separating the two expression. Okay, now you can see if the comma operator is there in the expression. Okay, so that time we are seeing the associativity of that comma operator. Okay, so here for comma operator, associativity is from the left to right, from left to right. That means this, if this expression is there, so this is also executed from left to right, and this is also executed from left to right. So here first you can see x is equal to 8 is assigned. That means 8 is assigned to x, y is equal to 2 is assigned to y, and in z there is no value. That means here we can say, let's consider garbage value or zero value is assigned to that z. Okay, now you can see for executing this expression like z is equal to y. So first this z is equal to y is executed, this one. That means this expression is executing from left to right. So z is equal to y. What is the value of y? Y value is 2. Okay, then comma. Y is equal to what? X. So our x value is what? X value is 8. Okay, then you can see x is equal to z. So what is the value of z? Z value is 2. You can see here, for when we have evaluated the first expression, so our z value is changing, so which is equal to 2. Now, if you just print these values like using this statement, printf percentage d percentage d x comma y comma z, so you will get the output as a 2, y value as 8, and z value as 2, like 282 is your output. Okay, so likewise we are executing the expression by considering the precedence and the associativity. Now one more point I want to tell you is that, suppose any x value is given like integer, x is equal to, suppose 5 is given, and the statement is there like printf percentage t x is right shifted by 2. Suppose this type of expression is given, so what you can do, like normally what we are doing, we are converting that x value or the decimal value into the binary, and then we are performing shifting operation on that binary value. So what you can do, if you or what you can do as a shortcut, if you can see the right shift operator. Okay, so in right shift operator, what you can do, you perform the division. You can perform the division on that x value. That means how this expression is evaluated, like you can see 5 divided by 2, or you can perform division by 2. Okay, so 5 divided by 2, what is the output, or what is the quotient here? 2. So this is for one time. That means like ki x is right shifted by 1. Now we want to perform ki x right shifting by 2, so that's why again we are dividing, so that 2 is again divided by 2, and we will get the 1. So this is for again for 1. So this right shifting means like x is right shifted by 2, so we will get the 1 as our output. Okay, so that means the right shifting is there, so that time you can consider the division, or you can perform the division. Okay, so same we can do for the multiplication as well, sorry, for the left shift operator as well. Suppose same is there, like x is left shift by 2, so how it will perform, like you consider 5 is there, so 5 into 2, what is 10 is there, so again 10 into 2, what is 20, so your output is what, 20. That means we are performing the multiplication for the left shift operator. So remember, for left shifting, we are multiplying by 2, and for right shifting, we are dividing by 2. So this is all about for solving the expression. Thank you.